Good day, sir. I am Fabian Torres, and these are my group members: Dwayne Domingo, Neville Silly, Joel Prince, Crystal Mentor, and Vincent Williams. Today we'll be presenting on geometry, which is a branch of mathematics, and we'll be looking at two types of transformation, which are reflection and translation. Geometry is a branch of mathematics that deals with the measurement, properties, and relationships of points, lines, angles, surfaces, and solids in space. In geometry, there are four types of transformations, which are translation, reflection, rotation, and enlargement. Today, we'll be looking at two types of transformation. As I said before, these two are reflection and translation. So both translation and reflection deals with the movement and position of objects. Now, my group member will present on reflection. What is reflection? Their teaching strategies, the teaching resources that they can use, and some real-world examples of same.
Hi everyone, my name is Crystal Mentor, and today I will be enlightening you on reflections, but in mathematics. Now, as we know, reflections are everywhere. When you look in a mirror, you see a reflection. When you look in the water, you can also see a reflection. Now, in mathematics, you can create mirror images of figures by reflecting them over a given line. Now, let's get into the definition of reflection in mathematics. According to research, they say reflection in mathematics is a type of transformation that flips a shape in a mirror. That is called the mirror line or the reflection line, so that each point is the same distance from the mirror line as its reflected point. Now, let's get into some real world examples. You have, let's say, this image here of the dog. Right? As you can see here, his reflection is the same as the original image. And at the bottom here, you have we have a mountain. In the water you can see the reflection, and here it's also the same shape or the same distance apart, right? Good. Now let's look here. We want to reflect this image, this triangle over here. Triangle P is what we will call the object. So we're going to create, let's say, triangle Q over here. Now, in order for us to do that, the exact distance we have of triangle P from the mirror line, triangle Q has to be the exact distance from the mirror line as well, right? So our first point is 1, 2. 2 squares away from the mirror line. Now, triangle Q has to be 1, 2. 2 squares away. So that's where our first point will be. The second point is 1, 2, 3, 4, 5, 6. 6 squares away from the mirror line. So our second point for triangle Q also has to be 6 points. So that is 1, 2, 3, 4, 5, 6. Now we have our second point. The third point is going up. So let's see how much that will be. 1, 2, 3, 4, 5. That is 5 squares away from the mirror line going upwards. So we have 1, 2, 3, 4, 5. Now let's connect the dots to see if we have our reflected triangle. Does it look the same? Yes, it does. Right? So now we have triangle Q being the same distance away from the mirror line as triangle P. So we call triangle P the object, and the reflected triangle we call the image. Now these two triangles are congruent because they are the same shape and the same size. Understood? Alright, that's all on reflection. Thank you.
Okay, so I will look at the effective teaching resources that we can use to teach reflection. So the first one here we have is one of the most common that we use every day, which can be an actual mirror. Right? Since reflection deals with the mirror image, it means that one of the simplest way that we can use to teach reflection to students is actually using a mirror. Also, we can use images that we can use line of symmetry that shows the reflection of images that are equal on the right and the left side, or we can also use it like up and down. So those are the two effective teaching resources that we can use, is the actual mirror and pictures. Thank you.
Today I'll be doing a presentation on translation. A translation, i.e. a transformation in which a plane figure slides along a straight line and changes its position without turning. As you can see here, is the object, so it just slides the image. It changes position without turning, it remains in the same position. Next, properties of translation. All points subjected to be translation undergo the same displacement. Next, translation preserves angles. Translation preserves the area. Translations preserve origination. And translation preserve the order of points. And here is an example. Alright? Same shape, same area, same points. All it did, it changed the position, but it remained the same. Thank you.
So here are some real-world examples of translation. We have the movement of an aircraft as it moves across the sky, as you can see here in the first picture. Second example is throwing a shot put, as you can see here.
Hello everyone, and I'll be looking at the effective teaching resources that can be used to teach translation. Now, teaching translation in mathematics can be enhanced with various resources such as visual aids. You can use diagrams, graphs, and geometric shapes to illustrate the concept of translation. Online tutorials. Websites and video platforms often offer step-by-step tutorials on translation with clear explanations. We have textbooks. Mathematics textbooks that include dedicated sections on translation, complete with examples and exercises. Educational games. Board games or online games can make learning translation more interactive and enjoyable. And finally, you have here peer collaboration. As Educator, we must encourage students to work together in pairs or groups to discuss and solve translated related problems so we can have an effective learning outcome. Thank you.
Okay, in conclusion, we have learned that translation and reflection are two types of transformation in geometry. They both deals with the movement of objects and their position on the Cartesian plane. We know that a reflection is a transformation that flips a shape or object across a line of reflection, creating a mirror image or of the original shape. A translation is a transformation that moves a shape or object from one location to another without changing its size, shape, or orientation. So it remains the same no matter the movement. Thank you.